Hey class, Miss Anderson here. Today we're going to get into angles. So we're going to learn about how to draw angles in standard position and then find coterminal and reference angles. So we're really getting into some trig stuff outside of geometry trig. So we have our standard XY coordinate plane here, and you can split this XY coordinate plane into 4 different quadrants. And so this is our x-axis, this is our y-axis. A couple things about the different quadrants. First of all, angles are measured counterclockwise. So we say that at the positive x-axis, this is going to be 0 degrees. And then we go counterclockwise. So the positive y-axis gives us that 90 degree, our first 90 degree angle. So that's 90. So the angles in quadrant 1 are between 0 and 90 degrees. And then both x and y coordinates in quadrant 1 are positive. In quadrant 2, you add another 90 degrees, and the negative x-axis here is going to be at 180 degrees. So angles in quadrant 2 range between 90 and 180 degrees. And something to note, in quadrant 2, your x coordinates are negative, but your y coordinates are positive. And then quadrant 3, 180 plus 90 is going to bring you to 270 at the negative y-axis. And so angles in quadrant 3 range between the values between 80 degrees and 270 degrees. And in quadrant 3, both your x and your y coordinates are negative. And then if we go full circle back to your positive x-axis, we've gone a total of 360 degrees. So one full revolution, one full circle is 360 degrees. So in quadrant 4, your angle values are between 270 and 360. And in quadrant 4, your x values are positive and your y values are negative. So when we draw angles and we call them in standard position, that's where your angle, your vertex of your angle is at the origin. That's the 0, 0, the middle. And your initial side, so the start of your angle is always the positive x-axis. And then you can measure angles positive or negative depending on which way you go. So I have given you all the positive angles, so that's starting at 360 and going this way. And so if you start your angle with the vertex at the origin, your initial side is right here, and you measure an angle this way, so counterclockwise, that is a positive angle measurement. Now I drew about 110 degrees. Remember, this was 90 degrees, so I drew an angle that was about 110 degrees there. Now if you start your angle here, and you go reverse this direction, then this makes a negative angle value. So you have positive angles that go counterclockwise and negative angles that go clockwise. Both angles always start at the positive x-axis, and these are called the initial side. This point is called the vertex of the angle, and then the side that it ends on is called the terminal side. So you have two sides, two rays, if you remember that word from geometry, two rays that form an angle, and one is called the initial side and one is called the terminal side. Should not be plural there, terminal side. And then whichever direction you draw it measures positive and negative. So this one is counterclockwise and this one is clockwise. So let's practice measuring some angles. So if I want to draw 120 degrees negative, I start at the positive x-axis as my initial side, and then I would go in the clockwise direction. So that would be negative 90, that would be negative 180. So every quadrant is 90 degrees. So negative 120 would be approximately right here. So I draw this directional arrow to show which direction your angle went, and then you have your terminal side, and so that represents my negative 120 degrees. Okay, if I want to draw an angle 400 degrees, we have to remember that all the way around, it goes 90, 180, 270, 360. And so we would have to go a full circle and then 40 more to get to 400 degrees. So you would start your initial side at the positive x-axis. You would go all the way around a full circle and then another, whoops, I did not mean that to make a circle, all the way around and then another 40 degrees, which is just about halfway, since halfway to 90 would be 45. And you want your directional arrow to show which direction you went and your terminal side to show that that's where the angle ends. And then 190, we start here, the vertex, you draw your initial side, positive, so we're going this way, that's 90, 180, 270, so 190 would be just over into the third quadrant, about 10 degrees. You get your directional arrow to show which way we went, and your terminal side, and that would represent 190. And then I forgot to tell which quadrant the terminal side lies in. So our quadrants are counted as quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and it goes in that order. So this one ends in quadrant 3, 400 degrees would end in quadrant 1, and 190 would end in quadrant 3 again. So notice that negative 120 and positive 190 did end in the same quadrant. They're similar. We have a new vocab word again that's called coterminal angles. So you'll notice that it has the word terminal in it. And remember, the terminal side is the side where the angle ends. Angles that are coterminal have the same terminal side. So for example, 45 degrees, you can see on this picture, 45 degrees starts here and ends here. And then 405 degrees goes all the way around and ends in the same spot. So starts here, ends here. So they have the same start and same stopping point. Same start and stop. And they are considered to be coterminal sides. So 45 and 405 are coterminal. Notice that if you start at 45 degrees, the only way to get back to 45 degrees is to make a full circle to get back there. So you find that coterminal side by just adding a full revolution to the angle that you started from, which is 45 plus 360 is 405. Or you can start here and then go backwards, negative 360 degrees, and you would end exactly where you started too. So if you did 45 minus 360, you would get negative 315. And that's a coterminal angle as well, because it starts here and it ends in the same spot as 45 degrees did. So start and stop in the same place, and they are just one revolution difference. So essentially you're adding or subtracting 360 degrees from your original angle to get back to where you ended. So to find positive and negative coterminal angles. So again, think about where 100 degrees would be. We are going to start at the positive x-axis always, and our y-axis up here is 90. So 100 would be just over that. So that is about a positive 100 degrees. Now to find a coterminal angle, I would have to go that 100 degrees plus another full revolution. So I would go 100 plus 360 more. So 100 plus 360 would be 460. That would be coterminal. So I'll draw that in red, 100, and then a full more circle. That would be 460. And then I can also go in the reverse direction. And so if I wanted to find this negative angle, you can think about it like this. Start at the 100 and then minus 360 to get back to where you're at. So 100 minus 360 would be negative 240. I don't want to do that wrong. Negative 260. Yeah, I thought that was wrong. Okay, so negative 260 degrees would be back to where you started. So that would be starting at the positive x-axis and going in the reverse direction, be negative 260. They would all end at the same terminal side. They all had the same starting side. So I added and subtracted a full revolution to get there. So 575 is over a full revolution. So to start this, I'm going to say 575 and I'm going to subtract 360 right away because I know that 575 is at least one revolution around. So it is one revolution and 215 degrees more. So 90, 180, 270, 360. I've gone 360. I have to go 215 more. So go to 180 and then a little bit more there. So 215 would be, or 575 would be right there. So now if I would go just originally go from the positive x-axis to this, that would be just that extra 215 that I went. So that is one answer for coterminal. So because my angle was above one revolution, I had to subtract to get my first coterminal angle. And you will have to subtract again to get your second coterminal angle. So then you're going to do 215 minus 360. And that leaves you with negative 145. And that's going to be the angle from the positive x-axis back this direction. Because then you're going negative 90, negative 180, and that would be negative 145 in there. So that would be positive and negative coterminal angles. So coterminal angles have the same terminal side. You get to the same terminal side by making one complete revolution. You're also going to learn about reference angles in this section. So we got to keep it straight by practicing coterminal, same terminal side. Reference angles are going to be formed by the terminal side and the x-axis. So to highlight that, they are formed with the terminal side and the x-axis. They are always a positive and they are always acute, which means that they are less than 90 degrees. So in the first quadrant, you can see you have your original angle in blue formed by the positive x-axis and the terminal side, and the reference angle would be the same because it goes back to the x-axis. In the second quadrant, if your angle goes into the second quadrant, so there's your original angle, the reference angle is the angle with the terminal side back to the closest x-axis. We want to make a less than an acute angle, so we pick the closest x-axis, so right there. So in quadrant 2, to find the reference angle, since the whole x-axis makes 180 degrees, you take your 180 degrees minus your angle, and that'll leave you with your reference angle. So 180 minus your angle. In quadrant 3, down here bottom left, you are going all the way past 180. And so to get back to the x-axis, your reference angle is right here. So your reference angle is from terminal side, x-axis. It has to make the acute angle, so you wouldn't use this one. And you would take your angle minus 180. So you take your big angle, subtract off the vertical line or the horizontal degree of the line, 180, and you'd be left with your reference angle. And then finally, reference angles in quadrant 4. Quadrant 4 goes all the way down around, and so the reference angle is back to the closest x-axis, which is the positive x-axis. And so to find reference angles in quadrant 4, you take the 360 degrees minus the angle that you have. So let's practice doing that. So we're going to sketch the angle, then find the reference angle. So first, make an XY axis, 120 degrees positive. Remember, this is going to be 90, 180. So we're going to go about 30 degrees over 190. So this would be my directional angle. This would be 120 degrees. Now, specifically, reference angles are formed with the x-axis and the terminal side, and it has to be the angle that's less than 90. So it would be this angle right here. Now, you can either use the angle with a little caret hat on it, or you can use an angle with a little comma to represent reference angle. Now this forms a right or a straight line, which is 180 degrees. So to find the reference angle, we're going to do 180 minus 120, which is going to leave me with 60. So that angle in red there is going to be 60 degrees, and that's going to be my reference angle. Reference angles are going to be really important in finding trig values along with coterminal angles. So all of this will be important once we get into finding some trig values here. But we got to practice using coterminal and reference first. So negative 150 degrees, we're going to start at the positive x-axis, but we're going to go clockwise this time because it's negative, and it's going to be just about here. And then we want the reference angle, so that's going to be formed with the x-axis, the x-axis and the terminal side, and you want where it's going to be less than 90. So this angle, not this angle, not this angle. So the smaller one. And then it's similar here where this full angle would make a straight line, so that'd be 180. So we can do the same thing we did in the last one and do 180 minus 150, and we want it to be 30 degrees. Now it's tempting to put negative 30 degrees, but our reference angles are always positive, so we're going to consider that to just be positive 30 degrees to make it back to the x-axis there. 35 degrees happens to be in our first quadrant. If we start right here, 35 degrees is just in our first quadrant, a little bit less than that, but right here. So if we are in the first quadrant, then your reference angle is equal to that angle because you are using the x-axis and the terminal side, and you go back to the closest x-axis, which would be where you started. So the reference angle for 35 degrees is 35 degrees. So you always want it to be less than 90. It's going to be positive. And then one more, 315. So for 315, we got to go almost all the way around our circle into the fourth quadrant. Remember, that's 270. And we're about halfway. So 270 plus 45 would be 315. So we're right there. And then our reference angle is going to be our x-axis and our terminal side, and we want the smaller one, so this angle right here. So because the whole thing makes a full revolution, which is 360, we can find just the piece that's missing by taking 360 minus 315, which would leave us with 45 degrees. So our reference angle here, oh wait, maybe it'd be 55 degrees. I think I'm off by a little bit here. 360 minus 315, I think it'd be 3. No, okay, never mind, I was right. So I just wanted to double check. So it'd be 45 degrees would be this angle right here. That's practicing finding reference angles. So we have to remember the difference between reference angles and coterminal angles, so make sure you practice that. All right, the last thing we're going to do is we're going to use the terminal side of an angle to find some trig values. So we have our terminal side of our angle lies on this point, negative 4, 3 lies on the terminal side. So we're graphing our angle from here, and then we're going to be going through the point negative 4, 1, 2, 3. So negative 4, 3 is right there. So we're going to go through that point. And so we're looking for the 6 trig functions from this angle. And we're going to do that by using the reference angle that we just found. So our reference angle is going to be right here. It's formed with the x-axis and the terminal side. And I'm going to use that reference angle and my terminal side to make myself a right triangle. So I'm going to drop this straight down. We always go back to the x-axis. And then I know these distances. Because I went 4 to the left, this is negative 4. I went up 3 to get to that point. That is 3 there. So I went negative 4, up 3. So that's why I know these two side lengths of that triangle. And I can use that to solve for your distance here or your hypotenuse. So you can say, let's just call it C for now because you're used to the Pythagorean theorem, A, B, and C. So then you do A squared plus B squared equals C squared. Be careful when you square a negative, you should get a positive result. Negative 4 squared is 16, 3 squared is 9. And then that would give me 25, and so C is 5. This is actually a Pythagorean triplet, 3, 4, 5, so that works out nicely. Then I have my angle is always next to my vertex. Remember, the vertex is at the origin, so the angle is always formed by the vertex. So that's my angle, which means that 3 is going to be my opposite side, 4 is my adjacent side, and 5 is my hypotenuse. So if I look at SOHCAHTOA, I can use these to find those ratios. So sine of my angle would be opposite over hypotenuse. And then cosecant CSC of the angle is the reciprocal of sine. Cosine would be adjacent over hypotenuse, and secant is the reciprocal of that. And then tangent of the angle is opposite over adjacent, and cotangent of the angle is -4/3. Now, the angle, the original angle and the reference angle have the same trig values, which is why reference angles are important. We're going to learn more about that later on, but that would be my answer for the 6 trig ratios that go with that angle. All right, thanks for watching.